Welcome to the Aerospace Advantage podcast, brought to you by PenFed. I'm your host, Heather Penney. Here on the Aerospace Advantage, we speak with leaders in the DoD, industry, and other subject matter experts to explore the intersection of strategy, operational concepts, technology, and policy when it comes to air and space power. So we've been focusing on next-generation weapons a lot here at the Aerospace Advantage, and that's for good reason. The combination of a rapidly evolving threat environment, from peer adversaries like China and Russia to terrorist organizations like the Houthis and Al-Qaeda, to operational factors that have evolved with an increased focus on the Pacific range, right? The need to project significant power anytime, anywhere are driving a new set of munitions capabilities. And we're at a critical juncture in this realm, with a generational wave of innovation shaping the weapons that will be available for tomorrow's warfighters. The last time we saw this much change was the precision strike revolution, which entered the fold at the tail end of Vietnam and was really put into effect in a major way during Operation Desert Storm. We improved on those capabilities over the years, introducing things like GPS precision guidance and miniaturized systems. But from a big picture, our munitions toolkit has looked pretty stable over the last 20 years, largely due to a stable demand signal. Operations in Afghanistan and Iraq required a specific set of capabilities, and our munitions inventory and capabilities matched that. That demand signal is changing a lot now, and it's got major implications for the kinds of munitions we are innovating and fielding. And so today we're pleased to have Major General Jon Norman, Air Force retired. He's with Raytheon now, and he's with us today to talk about these trends. Point blank, Raytheon is a global leader in the munitions realm, and they've innovated foundational technology, especially when it comes to precision strike, that we read about in history books. And they're also on the cutting edge of helping develop solutions for tomorrow. So General Norman, welcome.
Thank you very much. I'm looking forward to the discussion today.
So, sir, first off, I tried to explain it in the opener, but what's your take on why we're seeing so much innovation on the munitions front these days? You're incredibly close to the topic, given your role at Raytheon.
No, it's a great question. I think what you're seeing is a response to the changes in the evolution of the threat. So they're adopting defensive systems and offensive systems that have further and further range. And as we develop new weapons in partnership with both the U.S. and our allies, we're providing offensive capabilities and defensive capabilities that have that like range or better, so that we can defeat those technological advances that the adversary has. They've watched us in conflict for the past 20 to 30 years, and you can tell by what they're developing and what they're fielding, they're trying to counter what they've seen as very effective in those war fights. So we worked very closely with our U.S. government customers and the Department of Defense and our allies to provide the exact capabilities that they need. The other thing that you're seeing is that with mass rates coming in, it's pretty easy to deplete inventories. And so I think what we're seeing out of the U.S. and certainly our partners is an increased demand to make sure their magazine depth is adequate to fight those future wars. And so with that, they're all trying to get the most capability for the least cost that they possibly can. It's exciting, I think, for industry. It's exciting for all of our international partners to be involved in this. And I think that we have to have that close cooperation between both those defense partners and industry so that we can give them the best capability for prices that fit their investment profiles.
So we're talking about the imperative that is requiring us to change from the current capabilities we have, which they're mature, they're proven, they're effective. So it's range, it's the geography, it's the counters that our adversaries have. And it's not just the counters to the capabilities. We're going to need mass, right? Affordable mass. But first, let's talk about baselining where we're at today from a technological perspective, because we take precision strike for granted. You know, the ability to put a missile or a bomb anywhere on the planet with pinpoint accuracy, it's just expected. And that's a fairly recent phenomenon. When you first flew the F-16, sir, the aircraft was not equipped to drop smart munitions. And the same for me when I first showed up to the jet. But it's a very different story for today's warfighters. Could you talk to us about what it's like to fly and fight back then and contrast that to what pilots experience today?
I think what we're seeing when we first started in fighters, when I first started and you first started in fighters, is we were really relying upon time distance heading, and we were relying upon inertial navigation systems that drifted over time. Those have improved with ring laser gyro INS systems, so you have less drift over time. And we saw that massive evolution when GPS was introduced both into the platforms and into the weapons. What that allowed us to do is take advantage of our national systems that are giving very, very precise target location. And we can download that into the weapon, and it's as simple as putting the dot on the dot in the heads-up display or on your radar display and hitting weapons release. And you know it's going to guide there. It'll compensate for any wind effects over the time of flight of the weapon, and it precisely hits on the target. That allows us to manage our collateral damage for the target that we're intending to hit. It also allows us to have a level of precision that we never had when you're delivering these weapons manually. And that's been very effective, and I think it's been very much appreciated by the pilots. The other thing that I think that the services have done a great job, the Air Force and the Navy for the air-delivered munitions, is they've worked very hard on the pilot vehicle interface. And so that goes back into the operational development testing. It goes back to that great cooperative teaming relationship that I think industry has with the services, with the testing community, and with the acquisition community to make sure that we simplify all the way from mission planning to employment for the pilot and the air crew as they're employing these new weapons. I don't think that's going to change into the future. What is going to change is that our adversaries, because they have watched this over time, they understand the value that GPS brings to these weapons. And so that makes that a very lucrative target for them. And we've seen that in previous conflicts as they try and jam the GPS, both on the platform and to the weapon. And we have to have other ways that we can compensate and we can deliver that same level of precision. The way that industry and the U.S. government and our partners are looking at solving that is through collaborative weapons so that they can talk to each other. Mm-hmm. That helps with survivability, making sure that we hit the intended target, the correct priority intended target. The other thing that it does is it allows us to provide in-flight target updates. So if that target's moved during the time of flight of the weapon, then we're able to steer it in the correct direction. And then there's also the seeker advancements. So using millimeter wave, infrared, optical, or semi-active laser, we're able to give that weapon the opportunity to have the intended target in its field of view when it goes into the terminal phase, and we're able to precisely hit it. So it's a bit of a game of cat and mouse, but it's one that industry and the government is very excited to attack. The biggest challenge is doing all that, providing all that new enhanced capability for the seeker at an affordable price, and one that's manufacturable so that we can deliver these in mass, kind of to your other phone.
Yeah, I mean, being able to afford them so that affordable mass and the producibility so that you can scale manufacturing is really important, because if a seeker is too exquisite, it doesn't matter how good it is if you've only got a handful of them. You need to be able to have enough of that magazine depth that you talked about to be able to service all of the targets and be able to really collapse the adversary's capabilities. And, you know, it's interesting how that notion of range and how we expect our adversaries to counter existing data links or to counter our reliance on space and GPS, that's going to be something that we have to address not just only in our cockpits, but also for our weapons. So being able to deal with that uncertainty volume that you said, still being able to positively identify those targets in the end game, get those in-flight updates, and then also sort and collaborate amongst the weapons themselves autonomously, so that we don't have to necessarily be babysitting them, but we can really have faith that they're hitting the priority targets, they're hitting the aim points that they need to hit, even though some of those weapons within that swarm may or may not survive. That's really going to be a game changer going into the future.
I absolutely agree.
So, as I see it, we've got three major trends going on in the force today when it comes to munitions, right? So first is we're seeking to make what we've already fielded better, taking what we've already integrated onto the aircraft. And this is often the fastest way to get enhanced capability of the warfighter. And so the last time we had you on the podcast, we spoke about that and the improvements that you and your team are making to AMRAAM. And that was episode 77, and we've added that to the show notes. Second, we're looking at pushing the technological edge. Whether that's in extreme performance, new sensor phenomenologies, or survivability, this area is all about inventing new advantages that the adversary may not yet be able to counter. And hypersonics falls into that bin. Third, we're also looking to gain that edge in the area we call affordable mass. So we spoke about, right? Highly capable munitions that are also at the low enough price point that we can buy in major numbers. So could you help explain the drivers behind each one of these focus areas?
Sure. Well, I think the one that has the most value is that modernization, the PQ die of existing field integrated weapons. That's really the time and cost driver in fielding any new weapon. It's designing the weapon, making sure that it is operationally relevant, that it's reliable, most important, because you don't want to fly two missions, get one munition on a target, and that we're able to modernize that over time because the pilots have trained on it, they're very comfortable with it, they have confidence in it because they've used it, and giving them the improved capabilities over time. It's kind of interesting, you look at every new munition that comes out, they have a lot of electronic components in it. Mm-hmm. And think to your computer, think Moore's Law. So these electronic components, they evolve very, very rapidly. The typical development from concept to development to fielding, that time process is years in the making. And over that period of time, for something that's brand new, you already have components in there that are becoming obsolete, some electronic components. And so doing that architecture design of that weapon so that you can drop in the new technology and you can add capability to it is vital. And I think the services are doing a lot of work with that, with both the open system architecture, having government reference architecture that they're forcing upon industry. I think that's a great way to go. What we're seeing with a lot of the field weapons is as we do these modernization efforts to deal with the obsolescence, we're putting significantly more capability into these weapons, and we're able to unlock those future effects for them now. And AMRAAM's a perfect example of that. So when we did F3R, form, fit, function, replacement, we changed out a significant number of the cards in the front end stack and the guidance section because of obsolescence. But in doing that, we put much faster processors in there that allow us to do things with this air-to-air weapon that we've never been able to do before. We can change the way it flies so that we get it further range. We're able to deal with countermeasures that the adversaries can employ against it in ways we've never thought of. We can fly it in profiles that we've never thought of. And that sort of set the template for the way our company is approaching how we're modernizing some of our weapons. I'll go into Stormbreaker later because I think we have that as part of the discussion. But as we're fielding that and we're upgrading it, we're unlocking capabilities. We're also investing company money because, as you talked about, the nature of warfare has changed and we need further and further range. We need to be able to address targets in all weather, day or night. We need to be able to hit them when they're moving of all target types, soft, hard, and armored targets. So we've invested in demonstrating internally that we can ground launch this. We're looking at air launch modernization where we add a propulsion unit to it where we greatly enhance the airborne range of it. And that opens up the aperture for the addressable targets that we can hit with that instead of the current powered glide range of the weapon. Mm-hmm. And it gives planners a lot more flexibility with the munition that they have fielded that's being integrated into the platforms today that can address the target sets as they evolve over time, as they wait for the new weapons, the newer weapons, the exquisite weapons to come on board. You mentioned hypersonic, and it's interesting, people get very enamored with that. Hypersonic means it's going more than Mach 5. It's just faster. The advantage of a hypersonic weapon, it doesn't do anything new or magical. It just, over a greater range, it gives you an engagement cycle time that's significantly shorter. And that's very beneficial to the warfighter, all the way back to the C2, to the pilot in the cockpit, because you're able to stand off at greater ranges, but address that same target set that you would have to close very, very close with other weapons. You're able to address that same target set in the same amount of time from a greater distance. And that's exciting. It has challenges and has complexity to the weapon because as you fly at higher speeds, it certainly has a higher temperature environment that it has to deal with. That terminal phase is shortened in time significantly because the munition is flying so fast. It has inherent survivability characteristics to it because it is flying faster, so it's more difficult for the adversary to counter, and that's advantageous to our warfighters. And we're excited to be part of that as the Department of Defense tries to field those new weapons or is in the process of fielding those new weapons. I think to go into any detail on that, I'd really recommend reach out to the Air Force. It's their program, and I want to make sure they have control of the message for that.
Yeah, you bet. So, when we had you last on the show, the war in Ukraine had just begun, and other conflicts like the war in Gaza had not yet erupted. So back then you were concerned about the depleted missile stocks, the need for multi-year contracts to give industry some more stability in pricing and deliveries. Is that still a concern for you, or have we learned from watching these crises and really internalized the need for magazine depth?
Well, I think it's still very, very relevant. It's something that's carried consistently with the new administration. I think as you listen to testimony by our service leaders and the secretaries, that you'll hear a consistent theme that we need to make sure that our stockpiles are adequate so that we can have an effective deterrent. I think both the U.S. and our allies have learned lessons from the recent conflicts that they can't wait, can't have just-in-time munitions. They need to have adequate stockpiles so they're able to fight tonight. Whether it's a multi-year or it's a contract that gives options for year after year, all the above are very relevant. And it's challenging because maintaining that industrial base, it's not just the primes, it's all of our suppliers. Mm-hmm. And we have several common suppliers, and we need to make sure that as we're ramping our production up, say for AMRAAM, that we don't detract from another program that uses that same supplier. So that has to be done in a measured way. And there's groups within the Office of the Secretary of Defense and then certainly the services that are looking at that part. Congress is interested in it and how we manage and improve our industrial base so that they can do that throughput capacity. We've looked at other things with the services in the development and the fielding of these weapons that we can do smarter. We take some of these munitions that have been in production for years. Obviously, they've evolved over the years, but we build up test procedures for that production to make sure that the weapon works every single time. And they've added on top of test requirements in production that may or may not be necessary. And so we in industry and the government are taking a very hard look at that to make sure that we're doing the right testing at the right time and that we're delivering munitions that are fully capable. So if we can eliminate some tests in production because they're duplicative or they're really not needed because of technological advances, mm-hmm. that'll significantly improve that production throughput. I'm excited for that. I've seen a significant change in the way that the government and industry are partnered. Previously, we saw a lot of industry producing something and then it's just evaluated. And now all the way back at that production stage, you're seeing very, very close cooperation between industry and the government to make sure that we're maximizing our production. The other thing that we can do as industry is exercise what our expectations are for that wartime production. And so there may be ways of contracting in the future that we can run a wartime production for a period of time to make sure that both our suppliers and the defense prime that's doing the production are able to operate at that capacity and then go back down to a level that sustains all of our suppliers and sustains the factories at an adequate level. I found that when I moved from government into industry, I thought I had a good understanding of how everything worked. And what I didn't appreciate is the whiplash effect that it can have as we go in as government and we say we need 10,000 of X widgets. And then the very next year we say we only need 1,000. And then we want 10,000 a year after that. It's problematic because industry has to invest in that facility and all the test equipment that's required to be in production. Every supplier has to invest in the same so they can produce at the higher levels. When we go down to a lower level number, those industries often will make a business decision. Do they keep that factory just mothballed and with an expectation it's going to go up the next year, or do they reuse that space for a different production?
And what do you do with the workforce?
Yeah, same thing with employees. if they hire 1,000 extra workers to produce that 10,000 widgets a year, what do they do with those employees during that year where the demand is only at 1,000? And so the more we can level load industry, I think the better we are. And then exercise that surge for wartime production. That makes us more effective as a U.S. supplier. It makes the DoD more effective because they have a better assured delivery, both in peacetime and in conflict.
And as you mentioned, the surge capacity is very difficult to do when you need it, right? We can't just in time our munitions, our weapons inventories. We need to have those stocks, especially given the fact that we don't always get a vote when the adversary is going to choose when to start hostilities. And we will need to have as many weapons as possible to be able to address the targets and the challenge and the scale and scope of what is necessary to be able to win. And you can't necessarily be just waiting around hoping for the next budget cycle and being able to get to that surge capacity.
Manage your money on your time with 24/7 digital banking on the PenFed mobile app. Easily make payments, transfer funds, and deposit checks through mobile deposit.
That's music to my ears.
Learn more at penfed.org. Federally insured by NCOA.
So I really like what you had mentioned earlier about modernizing and updating those weapons. Like, for example, the Form Fit Function Refresh program that you discussed on AMRAAM. What more would you like to share with us about how you're incorporating some of those capabilities into future missiles or designs and how that affects lethality and survivability?
Oh, sure. Well, the thing I really like is the way something RTX is approaching our production. You know, we're measured, our brand is measured on how well we're doing on meeting the contracts that we've signed up to execute. And so we step back and taking a very holistic approach, and we're doing this process we call CORE. So think of it as an evolution of TQM. And so going all the way down to the lowest level within the company, we look at every process and every step, and we look at how we can do that more efficient. And it's yielded incredible results. It's been incredibly effective, and we've taken the lessons learned out of that optimization of the production line all the way back to the supply chain and our suppliers, and we've applied that to other programs in Raytheon. And our sister units over in Collins and in Pratt & Whitney are doing the same. You know, this was one of the things, the side benefits. I don't know if everybody anticipated it, but it was one of the side benefits of the merger that occurred a few years back, because we're able to work very closely with Pratt & Whitney and Collins, who have commercial production lines as well as military. And we're able to take a lot of those lessons learned and that core procedure and adopt that by Raytheon. And it's been very exciting. We've reorganized a few times internally in the way that engineering and supply chain and operations interact, and both with the programs and then between programs, so that we're able to share these lessons learned very, very efficiently. And we're seeing the results yield out across all the programs. So that to me is exciting. The other thing that we're seeing is the technological advances that we're seeing in software. So as we work with DevSecOps and our software designers, and we look across the industry at how some small businesses or new starts are doing things differently, we're adopting some of those changes as well to make our processes better. We're taking advantage of reuse of software. We're optimizing that. We're making it more open architecture so that it can integrate with different platforms, and it can open up the aperture for the warfighter on how they employ these different munitions. That to me is exciting. We're working with certainly artificial intelligence as every manufacturer is, to look at how we can do things differently and how we can take advantage of AI to have something that's very reliable, it's repetitive, and it works the first time every time. And I see a really bright future for both Raytheon and RTX, because I consider us a good industry leader on this, and we're working very closely with the government. It requires some changes, certainly on the government, in the way that both the Department of Defense operational test and evaluation, and then services operational test and evaluation, how they test, what actual live flight test requirements are there, and what can be done through modeling and simulation. And so as our models evolve over time and they become more and more accurate, and we gain that trust in that end user that the models are accurate, and we can replace a live fly with a modeling and simulation event. It'll help us both develop and field new weapons faster. And in doing that, it reduces the cost.
So I really like what you said about sharing best practices and knowledge of engineering and manufacturing across the whole Raytheon portfolio, because in that way, a rising tide lifts all boats. I'm curious, since we last checked in, there's been a significant increase in operational use of the AMRAAM and other Raytheon effectors. So what have you learned about wargaming and product capability in recent years?
Well, I think it's a good lesson learned as we look at the mass challenge that the U.S. government has placed upon industry, both the traditional defense primes and all the new starts. Reliability does matter a lot. When you look across some of the conflicts that have occurred recently, we've employed AMRAAMs that are 20, 30 years old, and they work every single time. We're seeing probability of hit, probability of kill significantly higher than was predicted,
Really?
even with these older weapons.
Okay.
Yeah, and I think a lot of it is when we look at probability of kill, it's across all cases, not just the heart of the envelope, but the very, very edge cases against significant countermeasures. The preponderance of the shots that have been taken recently, they're very much within the heart of the weapons envelope.
Okay.
And that reliability that's built in because of the partnership between the Department of Defense and industry that's built into a weapon like AMRAAM, it's paid off significantly because we've been able to use very, very old AMRAAMs and they work right the first time every time. So the users on the ground have significant confidence in the weapon. And then the aviation crews, the pilots and the weapon systems operators, they're employing these from air. They have significant confidence because they're working every single time. So as we look at affordable munitions, low-cost affordable munitions, they need to have the capability to survive to the target. They need to have the capability to be integrated with the platform so that it's easy for the aircrew to use them. And they need to be reliable so that when you hit the weapons release button, you hit the pivot button, it works every single time. I think all of us would find it very, very uncomfortable to go into combat and be in a position where it could be your life against your adversary's life. You hit the pickle button and the weapon doesn't. And so that's what we're trying to avoid. And we're trying to work very, very closely with the Department of Defense as we look at these low-cost affordable mass munitions so that we build that capability into it. And that's part of the requirement. It's going to be a balance because the more technology that you add, the more survivability that you add, the more performance capability that you add, whether it's speed or range, the more expensive that munition becomes. And so through modeling and simulation, we're able to show them how adding or taking away certain capabilities or performance measures of a munition, how it affects both cost, it affects both manufacturability, and most importantly, how it affects the weapons effect from performance.
And that's a really
reliability. So, no, go ahead. I'm sorry.
Yeah, I was going to say that's a really important piece of not just getting cost per effect, but operational cost, right? Because if you're throwing a lot of weapons that aren't reliable, can't survive the threat environment, don't have the necessary PK that they need to be able to have the effect that the planners rely upon, then you're going to have to throw a lot more, and the cost is going to go up dramatically. So that's a really interesting point. And I'm really glad to hear about the reliability of the older AMRAAMs. I mean, I'm not surprised, but what I am a little surprised about was the PK. And so that actually gives me a lot of confidence in our ability to stockpile munitions and still be able to use them and have them be combat relevant when we need them to. You were mentioning affordable mass, and I'd like to switch over and start talking about Stormbreaker, right? Because Stormbreaker is how you are bringing together the need for technology, the need for survivability, and the need for manufacturing and affordability. Can you talk us through the thinking further behind the Stormbreaker munition?
Sure. Well, it all starts with the target that you want to address, the threat. And so STB-1, small diameter bomb 1, and small diameter bomb 2, which we call Stormbreaker, that was a outgrowth of the U.S. deciding that we were going to adhere to the cluster munitions ban back in the 90s. And so to be able to address that target set, armored, moving area type targets. We needed a weapon that had the ability to precisely locate those targets, to be able to hit them in all weather conditions, and have a collateral damage estimate that was relevant to the battlefield. So what the Department of Defense did is they kind of took a two-putt on this. So they wanted to field something quickly because we had immediate adherence to the ban, and that was small diameter bomb 1. So that was a GPS-enabled weapon. It added standoff because of the capability improvement. So for a glide weapon, it was beyond 40 miles. And you could precisely hit a target that you had accurate GPS coordinates for, or you could employ it visually in a direct attack mode. We built into that the pilot vehicle interface so that it was easy to employ from the cockpit, and you could take advantage of your own display. You could take advantage of the data link coming in for the target coordinates to do real-time targeting, or you could do pre-planned missions against fixed targets as well. And it gave the pilots a level of comfort with how it was interfaced with the aircraft and how to employ with it. The ultimate goal was to provide a weapon that had the capability to hit armor targets, which the small diameter bomb 1 did not have. It just has a blast frag warhead. So small diameter bomb 2, Stormbreaker, that added a glass frag and shape charge to the warhead. It added a data link in there so that the weapons could collaborate with each other, and you could also provide it the in-flight target update. And then it incorporated a tri-mode seeker. So you still have GPS, but in addition to that, you have a millimeter wave radar, which allows you to hit targets through the weather. You have a double IR, so an infrared seeker built into this, and you have a semi-active laser seeker built into it. And it's all packaged into a very small tri-mode seeker. What this allows that weapon to do now is hit very fast-moving targets in all weather. It allows you to precisely find that target even if GPS is denied, because even over the time of flight with the IMU, the inertial measurement unit drift, it's still within the field of regard of that tri-mode seeker, which is great. It allows you to prioritize targets so that if the munition is lost, either through a malfunction or through enemy defensive action, it can reprioritize your priority targets are hit, and it allows us to attack area targets on the ground, at sea, that are moving, or fixed targets on the ground or at sea. That's just an incredible capability. And because the weapons can collaborate and through mission planning, you can set up area attack targets for it, and it has automatic target recognition built into it using the seekers, so that it can find the precise target that you want within that area and hit nothing else. And that is just a game changer for us, doing all that from a standoff range. And then, as I mentioned earlier, we're looking at ways that we can improve upon that, just the munitions. So it's already integrated or being integrated onto these aircraft. So how do we give it further range? And so adding a conventional propulsion to it, we can significantly enhance the range of this weapon, which allows you greater standoff, and it allows you to mass effects because the weapons collaborate with each other. Now we can have them fly different profiles that could help survivability or complicate the enemy's problem because you're attacking from multiple axes. And you can also provide in-flight target updates. So as it's seeing its time of flight for its engagement cycle time, if command and control identifies a higher priority target, we can provide that to the weapon. It'll update, they'll collaborate with each other, and then they'll hit that new target. So far beyond where we ever were with the cluster bomb munitions, but we can still address that same target set plus more. So I like the way that the Department of Defense designed this, and they work with the industry to make sure that we field significant capability enhancements to the weapon, and we provide it to the warfighters. And then we've worked very closely with the warfighters, both for employment, on how to simplify that and programming that into the weapons, all the way back to the mission planning steps, so that we make it as simple as possible, whether it's from a C2 providing an in-flight target update, or it's from the pilot doing a pre-mission load, simplifying that and making it as common with all the other weapons as possible so that they don't have to learn a whole new system. It's the last thing you want to do is provide an air crew weapons planning system that they have to learn everything new. We want to make that simple and very easy for them to integrate into their weapon shop.
Yeah, absolutely. I mean, putting that into the planning, into something that already exists, actually just increases the utility, especially given all the capabilities that Stormbreaker has. I mean, look, that's a wicked little weapon, right? And it is actually surprisingly small, even though you have advanced charges in there. How many can you fit on an F-15E?
The brew on there, they can fit 20 on there. The F-18, they use a different brew. It's a brew 61. They can fit 4, and they're working improvements that they'll be able to do 8 in the future. And then the F-35 can carry 8 internal. And so you have a pretty big magazine depth. And so think of this is what a new general purpose weapon looks like. So if we have pilots out there and they're doing close air support, because our magazine depth is so high compared to what a CBU would give you with that same platform, they can stay on station longer. They don't have to generate another sortie to go up and address that same target set. And so it provides greater flexibility. It gives us efficiency of force. And to your point, it's an incredible weapon. It's a 200-pound weapon that has incredible range and incredible performance characteristics that address all the target sets that we can envision right now.
Well, and the fact that you can upload them into the F-35 so you can take advantage of the F-35 stealth, providing survivability and additional penetrating range of the weapon. And so then when you release all of that, given that they're able to network together, fly different profiles, and even if you add, John, what did you say? How'd you call that? Propulsion?
Yeah, propulsion. So from ground-based, primarily what we've done on internal research and development is using the rocket power, so solid fuel propulsion to give it significant range. From the air, what we're looking at is conventional air-breathing propulsion. And so we're working with a bunch of different propulsion manufacturers to size it correctly for the weapon, to manage its thermal characteristics and its performance so that we can maximize the range of that weapon. The challenge that we'll have compared to a standard small diameter bomb 2 loadout, so for instance with an F-15 we carry 20, when you add that propulsion on there, you're also adding fuel. And so the weapon's going to grow in length a little bit, which means you'll carry a little bit less. But it gives a lot of operational flexibility because you can do mixed loads, kick down the door with the long range, and then use the shorter range that you have in mass to address those area type targets.
And especially if you're doing some of those longer range shots, once you get the propulsion on there, the net-enabled target updates are going to be really important. And I also think the net-enabled, you're really referencing also the ability of the weapons to collaborate, right?
Oh, 100%. And I'd say we're just at the cusp of that. So we have to work very closely with the government. It's interesting when you talk longer and longer range of these weapons with the capabilities, you still have to have the target ID. You still have to meet all the rules of engagement. And so being able to maintain that target custody over time, there's an absolute necessity to provide an in-flight target update to it. And you have to make the weapon smart. And we have to take advantage of both automatic target recognition. We have to take advantage of our collaborative weapons to make sure that we provide in real time keep out zones to the weapon. So if you had a target that was in an open field and it moved next to a structure that was an absolutely do not hit because of rules of engagement, the weapons during time of flight, they have to be smart enough to avoid that specific target so that we don't violate rule of engagement.
So you mentioned that Stormbreaker is currently qualified for the F-15E, so the Strike Eagle, and for the Hornet. Could you mind walking us through what's involved with this effort? It's called Seek Eagle, right? I mean, people don't just attach ammunition to an aircraft and see what happens. It's a very rigorous process that involves a lot of testing and live fly.
Yeah, absolutely. So Seek Eagle, look at it this way, an F-15E, and it has flight characteristics. So it can fly from the surface up to a very, very high altitude. It can fly from a low speed up to a high speed. And you want to provide a weapon that can be employed from every data point within that flight envelope. And that's what Seek Eagle does. So it looks at the very high angle of attack, very low speed. At high altitude, it looks at high speed. At low altitude, where the air pressure density is much higher. And it opens up that employment envelope for the pilots so that it's one less thing they have to worry about. So if they're flying their plane and they're flying within parameters, that weapon is going to match that parameter set. Same thing with the release sheet. And so during the CPO testing, they'll go up and they'll do all these different cases. They'll release it. They'll make sure that the weapon separates from the aircraft safely, that it is deployed, and it flies away without causing a flight interference to the aircraft. And that's vital. That's the last thing we want as a pilot, is for you to hit the weapons release and then damn thing smacks your plane.
Yeah, flies
so
back.
I look at that as you got to have that. The next thing is we have to validate that pilot vehicle interface works correctly. So if it's taking sensor input from a targeting pod, from a radar, or through data link, we test in all those environments during the developmental testing and operational testing to make sure it works as intended. And then we test it against all the different target types to make sure it has the weapon's effect that it's supposed to have. So when you drop it and you hit the target, that you achieve either a mobility kill or a destruction of that target set. And so that's pretty involved. And what you'll have is this, both through DOT&E and the service OT&E and Aflatech, so the Air Force, they'll develop a test evaluation master plan, and it goes through and they'll work with industry on that, and they'll go through all those elements, and they provide very good feedback the entire time. So if it's something that they notice there's an anomaly, it gives us an opportunity, once in developmental tests, to adjust the software, perhaps the flight software of the mission or the mission planning software, so that it works as it should work and as the pilots expect. A lot of times when these new systems are fielded in the acquisition community and it's under contract, they may not have insight into what works well for the air crew and what doesn't work well. And so in that developmental test and operational test, it makes sure that it's operationally suitable. So a perfect example of that, a pilot expects to be able to put the thing on the thing and then hit the weapons release button. But if they have 5 extra steps in there that can be automated, in that test, in that operational test, we're able to identify that. And then as that defense prime, we can go back in, adjust the software. We'll work with the platform manufacturer for their operational flight program update so that it all works as intended, and it makes it as simple as possible for the air crew. That can be a fairly lengthy process, years. As I talked about earlier, we're trying to use some of the modeling and simulation, both working with the platform manufacturer and then with us as the effects manufacturer, to make sure that we can identify through very high fidelity model and simulation how that weapon should interact as it's ejected off the aircraft, whether it's from an internal bay or an external carriage on the brew, and how it separates from that aircraft and does its fly out. So because we have very, very high fidelity modeling, a lot of those cases that we've had to test previously with live fly, whether through Seek Eagle or through the developmental tests and operational tests, we can capture those model and simulation. And as long as the government agrees with the fidelity of the model and the proof, it's one of those show me, then we can eliminate that part of the test evaluation master plan. And then we can just focus on those edge cases where maybe they don't have as much confidence in the model and the simulation, or they want to see it actually work in that flight. So that's it in a nutshell, but it's a lengthy process, and we're working very closely with the government to try and see where we can streamline that. And I think we're on a good path.
It's exciting to hear that you're using that kind of digital engineering to decrease the time span that it takes to be able to qualify a weapon. And thank you for expanding it beyond the Seek Eagle, because as you mentioned, the integration with the actual aircraft sensors, the OFP, even the HOTAS and how the pilot actually targets and then releases the weapon is just as important to how the weapon separates from the aircraft, as well as the weapon's effects that the munition has. So that's really important. So do you expect to see Stormbreaker on a bomber one day? I mean, I would expect that carriage capacity would be pretty large.
I absolutely do, especially if we can provide the longer range so that bomber is more survivable. If it's a stealthy bomber, it can go into a closer range, which is helpful, but every time it opens its bay doors, it can be more exposed. And so we want to provide as much standoff as we can. And I think the path we're going down with our internal research and development helps a lot with that. Who would have thought 15 years ago that we'd ever do CAS, close air support with a bomber? Yet we did that in Afghanistan. And they were highly effective because You have significant magazine depth, and they have incredible on-station time. I think Stormbreaker, because of its ability to address multiple target types from a standoff range, both fixed and moving, it'll provide a lot of flexibility to our U.S. bomber force.
So how are you seeing Stormbreaker change or enhance the options that are available to COCOMs?
I think what it does is it opens up a lot of target sets that are pretty challenging before. Take swarming boats. We've seen instances of that in the news where they come up and they either harass commercial shipping or they harass one of our U.S. ships or our allies' warships. And they're very, very difficult to deal with because they're coming from every direction. They're moving very fast, and it can be easy to overwhelm the defensive systems of those ships. By having Stormbreaker even from a standoff or a direct attack with the collaborative weapon and the automatic target recognition built into it, now we're able to address all of those swarming boats as they come in from a flight of 2 F-15Es. And that's an incredible capability where it could have taken 8 or more aircraft previously to try and hit those, and it was a very difficult target to hit moving at those speeds. Stormbreaker's designed exactly for that. So that opens up a target set that was challenging before. I think as we try to defeat threats that are in urban areas, it's always a challenge with some of the older munitions, the JDAMs or the GDUs, because it's challenging to control that blast frag. For the pilot in the cockpit, they're doing real-time math in public, which is always a dangerous thing for us, to try and make sure that we get the fuse setting right so that we have an adequate collateral damage estimate so that we don't hit something unintended with blast frag from that munition. Because Stormbreaker is a much more precise warhead, and we're able to address targets that were unaddressable before. And that's pretty exciting from a pilot's standpoint because it opens a lot of flexibility for you in the air for target sets that you may be asked to attack.
So clearly another value of Stormbreaker is the ability to surge your production, right? And we've talked about this through this podcast, and it's been a drumbeat that we've had here on Mitchell is the need to be able to care for the defense industrial base and do so with the right signals from the government. So what conditions would you need to scale to wartime? We see a lot of how the defense industry struggled to backfill U.S. reserve stocks when it began flowing weapons to Ukraine. And a lot of folks, they just don't realize that production rates can be a major challenge if the government doesn't provide the right demand signals and incentives. And you talked about this earlier. Having that steady demand signal is crucial for the health of an industry to be able to husband the engineering resources, the workforce, the facilities, the supply chain, and all of that. What do you need to be able to get there?
I think your point it's the consistent demand signal that both the U.S. and our allies are looking for as we go into ramping production on these munitions. There are components on these that have obscenely long lead times that are made by our suppliers. It could be in the raw materials, so think the metal. It could be some of the electronic components because there's so much demand from other weapons being produced as well as all commercial products that they're supporting with this facility. We saw it really come to a head during COVID when a lot of supply chains were shut down. And I think that the Department of Defense and the U.S. government reacted in a very reasonable and responsible way because they reached out to industry and they're pushing us and authorizing us to go out and qualify second source suppliers and third source suppliers. That's helpful to a point, but there's some exquisite technology in every weapon that we may only have one manufacturer for. So it's identifying those to the U.S. government and then with their help investing in those suppliers so that they can grow their capacity to meet what's an expected wartime demand. It's a delicate balancing act. There's certainly not a blank checkbook out there for the U.S. government and for industry. And so we need to do this very smartly. We need to work with them to help them prioritize which of those specific industries they're going to invest in. So think of things like a secure processor or rare earth minerals that all the manufacturers rely upon. If we can invest in those companies that are either producing those raw materials, the rare earth minerals, or aircraft grade aluminum or titanium or optics that go into some of the seekers. That's going to be incredibly helpful for industry, and I think it's going to resolve a lot of the consternation that both the U.S. and our allies have in our ability to produce at rate. Internally, I think the efforts that we've done under that core process I described earlier, that's going to help a lot too. So if we can eliminate unnecessary steps in the production, if we can work when we're doing these upgrades like F3R to incorporate designs that improve ease of manufacture, if we can incorporate weapon system and munition system open architecture into these weapons so that we can simplify the integration with platforms, then both producing and fielding new capabilities are going to be greatly improved.
So you mentioned allies and partners. How do they play into this?
Well, they have requirements as well. So, take Stormbreaker, for example. So we're integrating it on the U.S. platforms. The big export one is F-35. We're working with both the primes that supply platforms to these allied partners and the U.S. government to integrate on additional platforms. So it could be the F-16, it could be the F-850. It's work that we have to do with both the international affairs, the releasability, and with the U.S. Air Force to make sure that we both engage with these partners so that we can assure them a level of supply that satisfies their requirements if they're integrating this as a new weapon. And we have to work with the platform producer so that we align that delivery with their development of that operational flight program 8 that'll be required for that integration. It's a very active process and it's very iterative back and forth, but it's one that I think we can field and deliver new capability, and it's going to make our allies more capable. And more importantly, when we do operate in a major combat operation, we're never doing that alone as the U.S. So if we're doing it with partners and we have to disperse and we have to land at a partner base, at an ally base, we can load up their munitions on U.S. aircraft if required and still fly that same munition, and it still works the same way that our pilots are used to it working.
Mm-hmm. Yeah, so we've talked a lot about the top end of munitions development and then also about affordable mass. Where do you see these trends going from here?
I think that the affordable mass is certainly going to have legs. I think the big challenge, we had kind of discussed it earlier, but it's in the research and development. So there's been a lot of effort on that, and it's certainly good because it just elevates all of our game every time we can develop and then field new technology. But from the warfighting perspective, I don't want industry and I don't want our government just boiling chemicals in the lab. I need this capability fielded out to the warfighters. I wanted that, and when I was flying, I know you wanted that. You heard about all the development of something, and it just sat in a lab environment, or it sat in research and development. You really want that out in warfighters' hands as quickly as possible, satisfying the gaps that they have today. So I think that has to be part of the calculus as the Air Force and the Navy are looking at investment in weapons. What is the fastest way to field capability to the warfighter that gives them that fielded weapon that addresses the gaps that they're fighting today? I think we can do that with the affordable mass. I don't know that that the U.S. government has it right on where that price point is at. That's where it goes back into what capabilities do you want in the affordable mass. If you want them collaborative and you want extreme range and you want it to have a multi-sensor seeker on it,
that's not going to be affordable. Yeah, it's not going to be affordable anymore.
Yeah, it just rapidly becomes expensive. And so I think industry has to work very closely with the Department of Defense as they go down this roadmap toward what is affordable mass and what capabilities does it really need to have, and be able to answer that question. What's good enough for the price point we can afford? I think with the introduction of collaborative combat aircraft in the future, that's going to open the aperture on what's acceptable, what's good enough, and then what reliability is good enough for the PK that they want to have. Because that low-cost munition flying into a target area, it's another target that the enemy has to address. So even if it doesn't have the reliability to make it to the target to put the effects on it, it still demands their attention. And that may use up a surface-to-air missile that otherwise would have went against a weapon that is going to make it there, a higher cost weapon or a platform that's flying closer in. So there's a lot that goes into that. We're working with all the service departments with a rapid campaign analysis model that we have, that we take all their inputs out of something like AFSIM, and we show them high end and low end, and they're able to find where the needs in the curve for the investment are, and that's incredibly helpful. I think the more that we can war game these different effects and what capabilities they have, so that it'll help the services make decisions on, all right, how much capability do we really need in this weapon? I think the better off all of us will be. Selfishly from a pilot's standpoint, every weapon I carry, every time I deploy it, I want it to work. And so there does have to be a level of confidence that the weapon is going to work coming off the aircraft. It's not going to hang up on the weapon storage rack, or it's not going to dive right at the ground when you release it, that it is actually going to fly out. Otherwise, it's going to have very little value to the warfighter. I think that the services, as they're going down that path and they're looking at new weapons investment, which is pricey, I think that they're doing a good job of looking at what can they modernize on fielded weapons that really fills those gaps today and covers that time and space between now and sometime in the future when we can field these low-cost weapons in mass. One of the things that we're doing at Raytheon is we've been working with some international partners on MALD, Miniature Air-Launched Drone. So don't think of it as a traditional MALD. Think of it as it has a whole different airframe built onto it that's very, very manufacturable, which means we can reduce the cost. It has a different propulsion, which means you can double the range of this thing. And then inside, you get a lot of operational flexibility, because you can either have it do electronic attack or electronic protection, or you can put a kinetic effect in there, or you can put a reflector of some sort where it does look like another platform that the adversary has to address. The range is really interesting with this, because now we can have it go to the same range as the new fighters and the new bombers. We can have it go at an operationally relevant speed where it looks like a fighter, a bomber, or a CCA. And it complicates the enemy's targeting scheme, because they have to address that. I'm excited about that. It's definitely of great interest. I'm also excited that we're starting to look again very hard at electronic attack and electronic protection. Our adversaries certainly have, and we've seen that used to pretty good effect by our adversaries in some of the recent conflicts. And I think that both our U.S. and our ally interest and investment in that is going to benefit the warfighter in the future.
Yeah, I'm really excited about this. It takes us time to invent and develop and field a new aircraft. Our innovation cycle for munitions is so much faster. So I'm really gratified to see the attention that munitions is getting now, because we can innovate, we can improve, we can expand, we can really bring a lot of new ideas, creative ideas that create those kinds of dilemmas for the adversary in the munitions portfolio. So Jon, thank you so much for spending this time with us.
I really appreciate the time, and I hope that this interview will be listened to and read both by folks in the military and in the industry, and that in the future we just work closely so that we can solve these problems.
Lots of good stuff. Lots of good stuff. Thank you. And with that, I'd like to extend a big thank you to our guests for joining in today's conversation. I'd also like to extend a big thank you to you, our listeners, for your continued support and for tuning into today's show. If you like what you heard today, don't forget to hit that like button or follow or subscribe to the Aerospace Advantage. You can also leave a comment to let us know what you think about our show or areas that you would like us to explore further. As always, you can join in on the conversation by following the Mitchell Institute on X, Instagram, Facebook, or LinkedIn, and you can always find us at mitchellaerospacepower.org. Thanks again for joining us, and have a great aerospace power kind of day. See you next time.